Hello everyone, myself is Krishnaveni, working as assistant professor in the Marri Reddy Institute of Technology and Management. So here I am going to explain about the applied physics. So last 5-6 videos I have completed the quantum physics and solids. In that the first chapter is quantum physics and second chapter is solids. In that I have completed classical free electron theory and also quantum free electron theory. The continuation of that is next one is the Bloch theorem. So the Bloch theorem is the next topic of the solids in quantum physics and solids. So the next one is the introduction to Bloch theorem first, and let us go for the Bloch theorem. So before Bloch theorem we have the two theories. One is classical free electron theory and next one is quantum free electron theory. So which was completed in the last previous sessions. So next we will move towards the Bloch theorem. So what is a Bloch theorem and how he was assumed the assumptions, what are the assumptions of the Bloch, by now we will see. So here, so before Bloch theorem, there is a free electron theory, that is classical free electron theory, and also quantum free electron theory. So classical free electron theory was proposed by Lorentz and Drude. In this, there are some assumptions, advantages and disadvantages. Otherwise, assumptions, success and failures. So similarly, in quantum free electron theory was developed by Sommerfeld in the 19th century. In this also there are some assumptions, success as well as failures. So now this is also a development of quantum free electron theory itself. So Bloch theorem is also a development of quantum free electron theory. So there are failures in quantum free electron theory. That failure is we cannot differentiate the materials into metals and non-metals. So we cannot able to difference between metal and non-metal, which is a failure of the classical as well as quantum free electron theory. So that was successfully explained by the Bloch in the year 1928. So the differences between the metals and non-metals. Metal means conductor and semiconductor. Non-metal means insulator. So metal means conductor and semiconductor. Next, non-metal means insulator, that is non-conducting materials. So this differences was explained successfully by the Bloch in the year 1928. So how he was explained this metal differences between metal and non-metal by taking some assumptions. So what are the assumptions made by the Bloch? So here the classical and quantum free electron theory, the electron in the lattice, suppose this is a crystal. This is a crystal. In this, we have the lattice ions. So, in this lattice ion, the electrons are moving. In this, the electrons are moving freely inside. So, the electron cannot come out of the surface of the metal. So, this is free electron. This free electron means the electron can move freely inside the material or crystal. But whereas in Bloch, the electron is also moving freely, but there is a varying potential. What is a varying potential? That is, the potential near to the nucleus is zero. The potential is in between the nucleus is maximum. So in between the nucleus is a maximum potential, that is V maximum, and near the potential, near the nucleus or positive ion, the potential is zero. So that is the first point. The crystal lattice, which is composed of large ion cores with a regular interval. Regular interval means constant distance. So here, how much distance from here to here? That much distance between here and here. So that is here also A and here also A. So that is the solid is a composed of such atoms or ion cores with regular intervals, and conduction electrons. This conduction electron can move freely throughout the lattice. The electrons can move freely throughout the lattice. So next point is the conduction electron inside the positive ion cores, also in between the positive ion cores. So hence, instead of considering uniform constant potential as we have done in the electron theory, we have considered variation of potential. The variation of potential in classical and quantum, this is a constant potential. But whereas in Bloch, there is a variation of potential inside the metallic crystal with the periodicity of the lattice. That means the potential is minimum at the positive ion sides. Potential is maximum at in between the lattice ions. So this was the assumptions made by the Bloch to get the information about the metals and non-metals. So what is the assumption? That is the periodic potential, which is not a constant potential, and also uses the laws of the quantum mechanics. So that is periodic potential, which is in between maximum and near the nucleus, which is 0. These are the assumptions made by the Bloch. So by assuming that the Bloch was taken the wave equation, which is the wave equation, that is Schrodinger time independent wave equation in one dimension. Why we are taking the one dimension? Because the particle is moving along only x direction. Along x direction, the particle, that is electron, is moving. That's why we are going to consider only one dimensional Schrodinger wave equation. So what is a time independent Schrodinger wave equation in one dimension? That is d square psi by dx square plus 8 pi square m into e minus v by h square into psi is equal to 0. This is what the equation, that is Schrodinger. So this is also development of the quantum mechanics. So here what is E? E is the total energy of the electron inside the metal. And V, what is V? Potential, that is periodic potential. Periodic potential is represented by V of x. Why we are taking V of x? Because the particle is moving along only x direction. That's why V is replaced by V of x. So which is a periodic potential. That's why V of x is equal to V of x plus A. So periodic, how you define the periodic potential mathematically? That is V of x is equal to V of x plus A. So next, Bloch has shown that the solution of this equation 1. How he taken the solution of this equation 1? Suppose if the equation is x square plus 5x plus 6 is equal to 0, the solution of x is, the solution of the equation is the values of x. There are two values of x. So here also the equation is in terms of the wave function psi. Wave function psi. So psi is what? The solution of the equation 1. Psi is equal to how he was assumed, that is e power ikx into uk of x. So what is e power ikx? This is a sine wave function. And uk of x is modulating function. So modulating function and sine wave function, so which is represented by the Bloch. So whereas in particle in one dimensional box, the wave function psi is equal to only e power ikx. But in this, the Bloch has assumed that the solution of the equation is in the form of the product of the two values. One is exponential term, another one is modulating function. So where uk of x is a modulating function and e power x is the sine or cosine wave function. Suppose these are the lattice ions. These are the lattice ions. If the particle is moving along the x direction, only along x direction. If the wave function is taken on y-axis, that is psi of x. So how the particle is moving? Like a sine wave. The sine wave is known as e power ikx. The particle is in between, that is maximum potential. But near the nucleus, the potential is 0. V is equal to 0. V is equal to maximum. V is equal to 0. V is equal to maximum. Means this one is what? Modulating function, which is constant, which is modulating in between, here the nucleus 0 and between it is maximum, means it is changing. That's why it is known as modulating function uk of x. And which is a periodic one, means which is constant in between, that is a periodic function. So what is L here? L is the length of the one dimensional atom. So here this is the chain of atom, the length of the atom is L and interatomic distance is A. If the number of atoms is n, suppose 1, 2, 3, 4, 5, 6 and so on, the number of atoms is n. N into A is L. L is what? Length of the chain of the atoms in one-dimensional case. So here that instead of potential, whereas potential is V of x is equal to V of x plus n, a periodic potential. Similarly, the modulating function is also can be written as uk of x is equal to uk of x plus na. So from equation 3 and 4, what is 3? 3 is the wave function, solution of the wave equation, that is e power ikx uk of x. And also what is 4? That is if the particle is moving in the chain of atom, what is 4? If it is n number of atom, the periodic potential is constant, that is uk of x is equal to uk of x plus na. Suppose instead of psi of x, we are going to take the, in place of x, we are going to take the x plus na. If you take x plus na, wherever you have the x, write down the x plus na. E power ikx, we have in equation 3 e power ikx. So instead of x plus, we are writing x plus na. Similarly, uk of x into uk of x, this is equation number 3. So uk of x is, instead of x, we are going to write x plus na. So here e power ik, we can write this as e power ikna into e power ikx. So e power ikna into e power ikx. Whereas uk of x plus na is replaced by, again, modulating function is also periodic. So uk of x. So next we can write this, simplify this equation as like this. Why? Because e power ikn is as it is, and this entirely term is again equation 3. In equation 3, what is from equation 3? From equation 3 is what? What is equation 3? This is what? Psi of x. So what we got? So for psi of x is also same value. Psi of x plus na is also same value. That is wave function is also periodic. Potential is periodic. Modulating function is also periodic. Wave function is also maintaining periodicity. So this condition is known as Bloch condition, where psi of x is also same, psi of x plus is na is also same. This condition is known as Bloch condition. Similarly, we can write the wave equation. The wave function psi is having the complex value. Complex value means if you take I value, the complex value is minus I. So the wave function psi is a wave function and psi star is a complex function. So here the psi star of x plus na. Psi star of x plus na can be written as, again, here whatever psi x plus na, in psi star of x plus na, in place of I, we will write minus I. That's all. So e power minus I kna into psi of, in place of psi of x, we are writing psi star of x. So from equation 5 and 6, what we can write? The product of that, product of the two wave function. One is wave function and complex conjugate of wave function. So what you will get? Psi star x into psi of x. E power ikna, you will get e power minus ikna, we will get. So plus and minus e power 0. E power 0 is again equal to 1. So finally you will get what? Psi star of x into psi of x. So here the psi of x plus na, we are getting the modulus function. The product of this is psi of x plus na whole square, or modulus of psi of x plus na square is equal to psi x square, because psi of x plus na into psi star of x plus na, by multiplying the both, you will get the same value. So that is psi of x plus na modulus whole square. So what is this condition? Means that, what is the condition? This condition says that the electron which is not localized in a particular atom, the probability of finding the electron in the whole crystal is same. So the electron is not at all localized to a particular ion or lattice ion or atom. So the electron which is not belongs to not only a single nucleus also, but also belongs to all the nucleus existing in the crystal. So this condition says that electron can move freely inside the metal and which maintaining the periodicity. That is, periodicity means in between the maximum potential, near the potential is 0. So this condition is known as Bloch condition. So From this, we have the extension. That extension is known as Crani and Penny model, the development of zone theory. The third theory is zone theory. The zone theory was developed by Bloch as well as Crani and Penny. So, this Crani and Penny again still more the development that will be taking in the next class. So, with this, I have completed the class. I have referred this one is from the book known as P.K. Palaniswamy from Applied Physics book first year. So, thank you.